In an oxidation reduction reaction, electrons are transferred. Here's a redox reaction in an acid. Here's the oxidation portion, the reduction portion. The reducing agent loses electrons, becomes iron 3 plus, gives away electrons. The oxidizing agent here, manganese, here it's plus 7, absorbs those extra electrons and becomes plus 2. The galvanic cell idea is around this electron transfer. Since all that's happening in this reaction are electrons being transferred, these two things don't necessarily need to directly interact. In the galvanic cell, the reducing agent's over here, oxidizing agent over here, and since all that's needed are electron transfers, what's added is this means here, this wire, and this is going to conduct electricity, obviously. And what this is going to do is transfer those electrons. Over here, manganese at this end right here in the cathode, it's going to take electrons away from this part over here. So as a result, this end is going to become more positive and electrons are going to start moving in this direction. So it's going to start pulling, basically, electrons from here, where the iron is going to give the electrons here. So think of this reaction occurring here, and this reaction occurring here. As this thing starts absorbing electrons, this thing's going to lose electrons, it's going to gain them from over here where it's going to start giving up electrons, and thus this reaction takes place without them directly interphasing. This is how a battery works. This force, this pull, is called the electromotive force or cell potential, and it's measured in volts, which is joules per coulomb.